Hey guys, this is a review for Spiral 17. There are larger than usual number of problems on here. So I'm going to start off by doing all the odd ones, and if I see something I'd like to add on the even side, I'll add those in. Start off with looking at two functions, f of x and g of x, and I'm going to attempt to do f of x plus g of x, which means I'm going to take 5x minus 3 and add that to x squared, plus 3x, which in total gives me x squared, plus 8x, because I can combine those guys, and minus 3, and I'm done. The second one, f of 2 times g of 4. I'm going to find f of 2 first. And f of 2 is going to be 5 times 2 minus 3, which is 7. G of 4 is going to be 4 squared plus 3 times 4. 16 plus 12 is 28. And then I'm going to do those two multiplied. So 7 multiplied by 28 is going to be 140 plus 56, or 196. F of g of 2. So first off, I'm going to find g of 2. G of 2. And that's going to be 2 squared plus 3 times 2. 4 plus 6 is 10. F of 10 is going to be 5 times 10 minus 3, which is 47. All right. G of f of 1. I'm going to find f of 1. And that's going to be 5 times 1 minus 3, which is 2. And then g of 2 is going to be 2 squared plus 3 times 2, which is 10. I'm going to do number 8 also, because that looks fun. F of g of 0, so times g of f of 0. So I'm going to start off by taking g of 0. And that's going to be 0 squared plus 0, which is 0. Okay, and then from that I'm going to find f of 0. And that'll tell me this whole side. 5 times 0 minus 3, which is negative 3. So negative 3 is my left side, okay? G of f of 0. Let's find f of 0. And oh wait, I just did that. That was negative 3. And then g of negative 3, working my way out, is going to be negative 3 squared plus 3 times negative 3. So that's going to be 9 plus negative 9, which is 0. The right side of this is going to be 0. Negative 3 times 0 is 0. Number 9, given the equation, find the inverse. So first thing I'll do is I'll switch my x and y. So I got x equals 4y minus 3, solving for the new y. Get x plus 3 equals 4y. Y equals x plus 3 over 4. Do the same thing for number 10. I'm going to switch my x and y. X equals square root 2y minus 1. To get the y by itself, I've got to square both sides. X squared is equal to 2y minus 1. Going up top again, adding 1 to both sides, we get x squared plus 1 is equal to 2y, which means that y is equal to x squared plus 1 over 2. Okay, number 11. We are looking at another one of these, so y equals 2x cubed plus 1. Let's rewrite this as x equals 2y cubed plus 1, which means x minus 1 is equal to 2y cubed. I'm going to take the cube root of both sides. But first, let's divide by 2, because I really don't want to keep that 2 in there. It's going to make a mess. And when I do that, we get x minus 1 over 2 is equal to y cubed. Now we'll take the cube root of both sides, so I don't have to deal with that pesky 2 going on there. And we get that y is equal to the cube root of x minus 1 over 2. For number 12, we've got to determine if the following are inverses of one another. The big thing with inverses is if you plug them into each other and they are inverses, you will get an answer of x at the end. In other words, they undo each other. So when I plug these into each other, and for the sake of super funness, I'll find f of g of x first. That means I'm taking g of x and plugging into f of x. Okay, so that's going to be square root of x minus 4 squared. That means square root of x minus 4 times the square root of x minus 4 minus 4. When I distribute those, we get x minus 4, and then minus 4 square roots of x minus 4, minus another 4 square roots of x minus 4, then plus 16. Combining like terms, we have just an x. Minus 4 plus 16 is going to be plus 12. And then these guys are going to combine to make minus 8 square roots of x minus 4. Okay, big idea here. We didn't get x as our answer. Therefore, f and g are not inverses. Continuing with inverses, we're trying to sketch some inverses here based on original graphs. And to do that, I'm going to identify some points in blue and sketch the inverse points for those in red. That looks like 0, negative 4. That means my inverse point for that would be negative 4, 0. It looks like I've got negative 2, 0, and 2, 0. So my inverse points for that would be 0, 2, and 0, negative 2. Leaving me with an inverse graph that looks something like this. For 15, I'm going to stick with 0, 0. For 5, 0, or 5, 2, that's going to become 2, 5. And for negative 5, negative 2, that's going to become negative 2, negative 5. So my graph is going to look something like this. And it's going to be an up and down curve instead of a side-to-side curve. Next up, we're going to do some graphing and some solving of radical equations. I'm going to sketch a graph of my guys. I'll do the left 2 and then talk about the domain and range. Okay, I like sketching these with tables, and I'm going to start off by choosing a point that makes the inside 0. In other words, x equals 5. When x equals 5, if I plug it in, I get 2 times 0, 0, minus 3 is negative 3. 3, 4, 5, 1, 2, 3. Okay, if I try to go to, let's say, 4, we get negative 1 on the inside. That makes an imaginary number. We cannot go to the left of 5. So that's our end point. This is a square root graph. If I go up 1 to 6, we get the square root of 1 is 1. 2 times 1 is 2, minus 3 is negative 1. So 6, negative 1. And then the next nice number is if I put a 9 on the inside. Because if I do 9 minus 5, I get 4. Square root of 4 is 2. 2 times 2 is 4. Minus 3 is 1. That would be somewhere like here. My graph would look like this. My domain would be x is shockingly greater than or equal to 5. That's whatever made the inside of this equal to 0 or bigger. And the range, if I look at my graph, my y values start at -3 and go to infinity. So I'm just going to put y is greater than or equal to -3. Okay, for number 19, similarly I'm going to make a table. 4, 5, 6, 7, I don't know, that seems like a good number. I'm going to start -5 this time because that's what makes the inside of my radical 0. And I get 0, cube root of 0, 0, -0 is still 0, -4 is -4. 1, 2, 3, 4, 5, 1, 2, 3, 4. If I go down 1, cube root of, I'm sorry, I went up 1 there. There we go, down 1 to -6. Cube root of -1 is going to be -1. Okay, so that works. Negative -1 is going to be +1 minus 4 is -3. Okay. The next nice number going backwards is going to be way off my graph, so I'm not even going to bother with it. Let's look at my positive side of this graph. So -4. -4 plus 5 is 1. Cube root is 1. -1 minus 4 is -5. And that's going to end up being like there. The next nice positive number, so after we get 1 on the inside is when we get 8 on the inside, because the cube root of 8 is 2. That's going to happen at 3. So 3 plus 5 is 8. Cool. And cube root of 8 is 2. -2 minus 4 is -6. And that graph is going to go something like this. And this has a domain, because it's a cube root. My domain is that x could be all real numbers. And for the range, the y could be the same thing. Since this graph goes on forever in both directions, positive and negative, left and right. Okay, solving some equations. We're going to continue with these guys. Looking at number 21, I've got the square root of x plus 5 is equal to 12. First thing I want to do is to get rid of that square root. And in that, I'm going to take the square of both sides. I get x plus 5 is equal to 144. Solving that, I get x is equal to 139. To check to see if this is extraneous, I'm going to plug that back in. So we get 139 plus 5 inside the square root is equal to 12. That tells me the square root of 144 is 12. In other words, 12 is equal to 12. No extraneous solution. For number 23, let's clear out some of this junk first. I'm going to try to get that piece by itself. And to do that, I'm going to minus 3 to both sides. We end up with -2. The square root of x plus 1 is equal to -8. Divide both sides by -2. And we get the square root of x plus 1 is equal to +4. If I were to square both sides of this, we end up getting 16 is equal to x plus 1. Therefore, x is equal to 15. Plugging this back in to the original equation, we get 3 minus 2 times the square root, 15 plus 1, is equal to -5. 15 plus 1 is 16. Square root of that's going to be 4. 3 minus 2 times 4 is 8, is equal to -5. We get -5 equals -5 once again. Nothing is extraneous here. Looking at 25, I'm going to try to get that cube root piece by itself. Let's start off by adding 2 to both sides. We get 1/4 the cube root. 5x plus 2 is equal to negative 1. Multiply both sides by 4 to get rid of that 1/4. To get the cube root, 5x plus 2 is equal to negative 4. I'm going to cube both sides, and in doing that, we get 5x plus 2 is equal to negative 64. Minus 2 to both sides, we get 5x is equal to negative 66. And when I divide both sides by 5, we get x is equal to negative 66 over 5. Plugging that back in to make sure it's not extraneous, we're looking at 1/4 the square cube root of 5 times negative 66 over 5 plus 2 minus 2 equals negative 3. My 5's cancel out. I get 1/4. The square root, negative 66 plus 2 is going to be negative 64. Minus 2 is equal to negative 3. Cube root of negative 64, sorry. That's going to be 1/4. Negative 4 minus 2 equals negative 3. Negative 4 times the 4th is negative 1. Minus 2 is negative 3 equals negative 3. Nothing extraneous there either. Finally, I'd like to look at number 26, just to give us a glance at a challenge one. Here we've got a square root of x plus 4 is equal to x minus 2. Let's square both sides. On the left, that gives us x plus 4. And on the right, that can be multiplied out, x minus 2 times x minus 2, to get x squared minus 4x plus 4. Bring everything onto the same side. We are going to have x squared minus 5x is equal to 0, which factors into x times x minus 5. In other words, x equals 0 and x equals 5. I've got to check to see if these are extraneous or not. When I plug these in, we get the square root. 0 plus 4 is equal to 0 minus 2, which means that 2 equals negative 2. That means that one's extraneous. When I plug 5 in, we get the square root of 5 plus 4 is equal to 5 minus 2. The square root of 9 is 3. 5 minus 2 is 3. That one is not extraneous. Next up, we're looking at variation and graphing rational functions. And I'm going to start off with my variation piece. Recipe for 2 dozen corn muffins. Okay, so that's 24. Calls for 6 cups of flour. If the number of muffins varies directly, okay, so I'm going to call this muffins and flour, so M and F. So the number of muffins varies directly means I've got some kind of slope times F, number of cups of flour. Write an equation to model the situation. Okay, let's put these numbers in. So 24 is equal to K, that's my slope. F is going to be 6 cups of flour, which means that K is equal to 4. All right. That means my equation is going to be the muffins is equal to 4 multiplied by the number of cups of flour. To make 6 dozen muffins, I guess I should have done this in dozens instead of numbers of muffins, huh? Because that's 72. So 72 is equal to 4 times F. Divide both sides by 4, and that should be 18 cups of flour is my number of cups of flour. That came out a little bit awkward there. And that makes sense, because if we're going from 2 to 6, that's times 3. 6 times 3 is 18, so that gave me the same scale factor. To drive to visit friends in Wisconsin takes 20 hours if you go 60 miles per hour, okay? If the same time it takes to drive to Wisconsin varies inversely, all right, so I've got time and velocity. I guess that's speed, really. So time equals, and this is going to be some kind of scale factor, divide by s for speed, or time times speed is equal to some kind of constant. Okay, how long would it take if we drove 70? So let's start off with my original numbers. I kind of like this one because that tells me what k is right away. So 20 times 60 is equal to k. That gives me 1200 is my k value. Okay, how long would it take if we drove 70? So 1200 is equal to time multiplied by 70. If I divide both sides by 70, that ends up being 120 over 7 hours is the amount of time that it takes. Okay, for these guys we're going to sketch some graphs, and we've got to identify some important points. I'd like you to notice these are both linear over linear, nothing too fancy still here, but let's identify these points first. My vertical asymptote, what happens if I try to make the bottom equal to 0? So 5x minus 1 is equal to 0. That means that at x equals 1/5 I have a vertical asymptote, by the way. My domain is going to be all reals, except that x cannot equal 1/5. Those things are tied together really nicely. If there was something to factor, I might end up having a hole instead of that for the vertical asymptote, but in this case, since there's nothing to factor here, we're in good shape. Horizontal asymptote, I'm going to plug in a really big number, and in the process of that, I'm going to find out this comes out to be about 1/5. Another way of looking at this is if these are the same degree, and they are, if I divide the leading coefficients, I get 1 over 5, or 1/5. Okay, my y-intercept, I'm going to plug in 0 for x, and I get 0 minus 3 over 5 times 0 is 0 minus 1 is equal to 3. Alright, I'm going to add my asymptotes while I'm here. And there's my horizontal one. Y equals 1/5. Let's see if there are any x-intercepts. We had a shortcut if you only have one term. That numerator is equal to 0. So in this case, that's going to be a positive 3. Okay, so if that's 1/5, there's 1, 2, 3. That gives us a point in two opposite quadrants of my graph, which should give me a pretty good idea that we have a hyperbola that looks roughly like this. For number 30, we're going to follow a similar setup. We're going to find the vertical asymptote. In this case, x plus 4 equals 0, so x equals negative 4 would be my vertical asymptote. That also means my domain is all real numbers, such that x cannot equal negative 4. For horizontal asymptote, I can plug in some really big numbers, or notice that these are the same degree again. I get y equals 2. For my y-intercept, I'm going to plug in 0 for x, and I get negative 7 over 4. And for my x-intercept, I'm going to set the top equal to 0. 2x minus 7 is equal to 0. That means that x is equal to 7 over 2. Let's plot these points and see what we get. Okay, so negative 4 for my VA. Negative 4. We've got a horizontal asymptote of positive 2. We've got a y-intercept of negative 7 over 4. So that's between negative 1 and 2. And we've got an x-intercept of 7 over 2. So that's going to be between 3 and 4. So I've got a pretty clear idea about what's happening down here. I'd like to plug in a point that's less than -4, just to make sure that that's where I think it is. So we get 2 times -5 minus 7 over -5 plus 4. 2 times -5, -10, so it's going to be -17 over -1. And between those two, we got somewhere way up here, which definitely would give us the part of the hyperbola we need. And finally, that brings us to the final section of our spiral review, which is simplifying rational expressions. And looking at these, in general, our goal is going to be to factor as much as possible, at least for the first two. Then we'll talk about some common denominator stuff for the second ones. All right, first guy. Numerator, I'm going to factor a 2 out of that, and that gives me x squared minus 4x minus 45. I can further factor that to x minus 9 and x plus 5. The denominator, that's already ready to factor. That can factor into x minus 9 and x plus 4. I'll carry that down. Okay, I'd like to take a moment to identify things that x cannot be. X cannot make the denominator 0, so x cannot be 9, and x cannot be -4. Because now I'm going to do some canceling. I see that I've got x minus 9 over x minus 9. Those can cancel out. And that leaves me with an equation, or an expression, 2 times the quantity x plus 5 over the quantity x plus 4 when x cannot equal 9 and x cannot equal 4. -4, sorry. Similarly for 32, we got way more to factor. I'm going to start by factoring top left. I'll do each of these in a different color. And then top right, and then bottom left, bottom right. First guy is good for me to factor already. Looking for numbers that multiply to -88 and add up to -3. That's going to be, well, let's go with 11 and 8. So we got x minus 11 and x plus 8. By the way, if you need help with factoring, you need to come for help. If you cannot factor these, you will be in some trouble. Bottom left, I'm going to take a 2 out first. X squared plus x and minus 132. Okay, by the way, that's 12 times 11. That's going to turn into 2, and then x plus 12, and x minus 11. And again, the top of that is going to be x minus 11, and x plus 8. Okay. Top right, I'm going to take a 4 out first, and we get x squared plus 14x and 132. I think it's going to be 28. Nope, definitely not 28 because that's too small. So it's going to be 25 plus 8 is 33. So I get the 4. That factors into x plus 7, and it does not factor into x plus 7, x plus 11, and x plus 3. And then finally, we're looking at the bottom right. X squared minus 64 is x plus 8, x minus 8. I'm just going to carry that down. Okay. First thing we do is identify things that x cannot be. X cannot be -12, positive 11, -8, or positive 8. Nice. Okay.
The next thing is that I'm going to do some canceling. I've got an, I'll do this in, not eraser, highlighter, that's what I want. X plus 8 and X plus 8. Those can get canceled out. Cross out, cross out. We've got X minus 11, X minus 11. Those can get crossed out. And I think that's it. Oh, and then 4 and 2 can reduce to 2 over 1. So I'm going to have, aside from this domain restriction, 2 times the quantity of X plus 11 and X plus 3 over X plus 12 and X minus 8. A lot of work, but it's just factoring and reducing. Looking at number 33, in order to add things, we know we need some common denominators. I find the easiest way to do this is to factor stuff. And here I've got 5ab squared, and here I've got 10b. Okay, so this could be 2 over 5 times a times b, and 2a over 5 times 2 times b. I'd like to notice that my right side has a 2 that my left side doesn't have, so I need to add a 2 over there. And my right side needs an a. And if I multiply the bottom, I'm going to multiply the top. And it needs one more b to make sure that we have the same number of pieces in each one. On the top, that gives me 4 plus 2a squared. And on the bottom, we've got 5 times 2 is 10. A, b squared. And then that could be complete. We could have done some reducing on the second one that would have made that a little bit easier. But that's okay. We've combined those effectively. An acceptable alternative answer would be 2 plus a squared over 5ab squared. For the one on the right, we're going to do some factoring. And we end up with 2x. And we're going to have 3. And that's going to be 30. Oh, that's 20 when you add it. Okay, so we end up with x plus 4 and x plus 5. On the right side, we're going to have 5, and that's going to be x plus 5, x minus 5. Okay, again, I'm going to look for things that the other piece doesn't have that I need to add in order to make these denominators common. I notice that I'm missing a 3 on the right, so I got a 3 over 3. And I'm missing an x plus 4 on the right, so we need an x plus 4 on the top and the bottom. Okay, on the left, we're missing an x minus 5. I'm going to add that into the top and the bottom. Okay, now that my denominators are the same, I'm going to combine some things as much as I can. Do some distribution. We get 2x squared minus 10x. Minus 3 times 5 times x, that's 15, x. And then minus 15 times 4 is 60. Okay, the bottom is going to be 3, x plus 4, x plus 5, x minus 5. Sometimes this will factor in such a way that you can reduce some other things. I'm really hoping that is not the case here, but I'm going to double check just to make sure. So we get 2x squared minus 25x minus 60. Looking for things that multiply to negative 120 and add up to negative 25. I don't think there are any. We got 12 times negative 10, no. We're going to have 24 times negative 5, no. 30 times negative 4, no. 40 times negative 3, no. 50, 60, 60 times negative 2, nope. And 120 times negative 1, definitely not. Okay. And then the bottom, we're just going to have 3, x plus 4, x plus 5, x minus 5. Just for the sake of being mathematically accurate, I also do need to say that x cannot equal negative 4, negative 5, or positive 5, because those would make the bottom 0. And I should have done that on 33 also, to say that a cannot equal 0 and b cannot equal 0. That's all she wrote.